Okay, so let's get started. So my name is Junaid Ahmed, and today's module that I'll be presenting is data access, and I'll be presenting it with Tanner. So Tanner had recently given us a very good presentation about introduction to Python. And so now leading from introduction to Python, now this module will give you an introduction, an idea about how we can access different data sets using Python programming language. Okay, so okay. So what is data access? Data access is the on-demand authorized ability to retrieve, modify, copy, or move data from IT systems. So it is the means by which users can get data and its location in an authenticated manner approved by the organization in possession of the data. And among many other different programming languages, Python is one of the languages that is incredibly flexible and has a lot of open source libraries for accessing and processing data. And so there are different categories of from where data is accessed from. So three main categories are local files, databases, and application programming interfaces. So local files are simply the files which are available on your system on your laptop that you work every day. And databases are organized collection of structured information or data that is typically stored electronically in a computer system. So database is essentially it is usually controlled by a database management system, and together the data and the database management system along with the applications that are associated with them are referred to as a database system. And now talking about application programming interface. So today we'll be accessing datasets using this API. So many of you might not have heard about this before, but API is something like, you can see an example over here. So for example, you go to a restaurant, you order something to the waiter takes your order, he goes to the kitchen, and then kitchen, okay, sorry, here's a comment. Okay, and so waiter takes your order to the kitchen, and then kitchen it processes your food and provides the order to the waiter, and waiter is going to deliver it again to you. So considering this example, say you are now going to download a data from a website using Python, and now you're not directly opening the website, but you are using Python. So what API is going to do is that it is going to collect everything that you want from that website. It will go to that website, place your order. The website is going to prepare your order and give it back to your API, and then you will get it delivered to yourself through whatever language you are using. Say in this case we will be using Python. So this is essentially the first important thing that you need to understand what is API and how you are going to access data using API. So we will be using basically Python to generate API for the websites that we are going to download data from, and then we'll be getting our data directly from Python. And so yeah, another thing also. So for example, if you guys have any confusion at any point, please do not hesitate to drop either message in the chat box, or you can directly unmute yourself and ask me a question. So basically, I just want to give an overview because this activity is going to be mostly about, we'll be using Jupyter notebooks directly accessing and downloading datasets. But before we do that, it is essentially important that you know what are the basics. Actually, you should know, should have an understanding of regarding the application that you'll be using. So, talking about different sources of water and energy data. There are various sources of water and energy data, and these are the sources. Particularly, these are about USA, but this NASA Power, the fourth one, this also provides because it has data from different satellites that give you data for different places around the world. And so these are actually the interfaces of all these sources of water. Basically, USGS, so it has an extensive sort of data sets available. You can download data from different satellites. Say, for example, Landsat imagery data is available over there. And then this is not, only specific to USA. So this Landsat data is covering the entire globe. And you have this discharge data, and different sorts of data set is available on USGS website. And then again, talking about NOAA, so National Oceanic and Atmospheric Administration. So it extensively deals with a lot of data sets, say meteorological or others. You can download directly from it. And then there's a National Weather Service for USA. Lots of gauging stations that are installed countrywide. You can get data from National Weather Service, and National Weather Service also embeds some of the services from NOAA, so they are somehow also integrated, and you can get the stations of NOAA are also available on National Weather Service. And then this NASA Power website. So these you can get meteorological data from here, and you can also download different sort of satellites data. I remember I downloaded Mira satellite data from here for temperature and precipitation. So you not precipitation, sorry, for temperature and other products. So you can go to these sites and download data from there. So these are some of the sources from some of the various sources that we have available with us. There are lots of other websites also. And now coming to data sources about building energy domain. So some of you might be interested to download data from building energy domain. So these are some of the sources. So this is US Energy Information System. So this is the website from where you can download data regarding this building domain. And the others on the left side, you can see there's a specific library for that that says EIAPY. So basically, whatever you can download from this website by yourself, you can actually download it using this, API from using this API that we will see later on. But I'm just giving overview. So you can use this library from Python and access the data from Python using this specific library that has been made for this particular data source. And similarly, some of the other sources. So this is another source of building data and tools. And this, you go to this website, you can download data by yourself. But on the other hand, Python specific libraries have also been created to access that data from here. And you have this API written here. I will explain how do we download this data in one of our activities, but this is just an overview, like, if somebody is interested. And another thing also, in the last presentation, you also heard about GitHub. So GitHub has a lot of database available. There are different, repositories that are available. So one of them, for example, this is a building data genome project. So it's an entire project, and I think we have one of the activities in this module also related to downloading data from this building data genome project for using GitHub. So this is also one of the sources from where you can download data related to building energy domain. So the idea was to just let you know that there are different sources available from where you can access and download data, and then you can download the same data using Python. And now we will see later on how do we download it using Python. So before we get more into the details, just a basic understanding what are comma separated value files. So I think a lot of you might already aware of what a CSV file is. So CSV files are they basically it's a method of storing data within a single file format. So over here on the left side on the screen, you can see this is a CSV file example. So you can see all the values are separated by a delimiter like a comma, or in this case. Then the middle one, it's Microsoft Excel interpretation. And then on the right side, this is a Python, data frame Panda. So and the last module, Tanner explicitly and clearly, gave some very good examples like how we can read data from a CSV file or an Excel file, and then how does that data looks like within the Python console, in this case, we are using Jupyter Notebook. So how does that look like? So the illustration of, your file in the Python in the Jupyter Notebook is actually we call it data frame. So how does it look like entirely when you call it in your, for example, in this case, you are calling it in your Jupyter notebook. So this is how it looks like in Python. This is the same thing in Excel and then in CSV. So these are just to, these are just refreshers. So before we get into details, just letting you know. So today's module will be about Python activities. So we have in total 4 different activities. The first one is assessing the temperature precipitation data from NOAA. So I told you, I gave you a brief introduction about what NOAA is. It's a source from where you can download different sorts of data sets. And then second activity will be specific about downloading stream flow data from USGS. And then the third one is downloading netcdf file from Aphrodite. So it's a temperature product, and then we'll convert it to a time series. So Aphrodite product is basically for the Asian countries. So some of the audience from Asia might be interested in this product also. And then downloading the fourth activity will be downloading a CSV file from the Building Genome Project via repository. That example I showed you instantly. So we'll be using Python to access and download this data. So starting with the first activity, accessing the temperature and precipitation data from NOAA. So before we go into how we are going to download this dataset using Python, I just wanted to want to show you an example. So for example, most of the data on this, from NOAA, you can access using this climate data online. So let me just show you, for example, if you are using this manually, so you will just go to climate data online. You will open the link, you will go to the data tools. So this is just an illustration of how we are going to download data if we are not using Python. So you have to find a station, or you can use the other way. So for this manner, you should enter now the location. So in this case, let us go with Dallas. For example, I want to download data from the Dallas Fort Worth International Airport. So now that I have specified my location, now for example, I'm interested in daily summaries. I select that one, and now the range, say for example, 1st May, I'm applying this one. And then over here, you can see here it appears, uh, the station. So you can see the station name is written over here. Its ID is also written over here. Its lat longitude, and then its period of coverage. So if you so the the reason why I'm telling you this is, before you download any data via Python, you should be aware of all the process, for example, how to reach to that data, because of course Python is just a programming language. You have to tell the language that this is what you require. So in order to specify your requirements, you should know what is the location, what is the data you are interested in. So, and how do we create, a URL from where Python will reach to the particular data? So you will need these IDs, everything later on. So I'm just telling you. So for example, manually now I'm down going to add it to my card, and then I will go to the card because now I want this data. So for example, I want it in a CSV format, and then this is the data range that's already mentioned. So I continue. And then you can specify, like for example, precipitation, air, wind. I want every of this daily summaries. So you select it, you continue, and then this is the summary of what you have requested. And this includes all the different meteorological variables. You provide your email address. In this case, I'm providing my. Then if I submit my order, then this is an order now that you have requested NOAA that you want this data set. And now NOAA will first send you a confirmation email that okay, they have received your request. Then after a while, they will give you your data in the form of CSV. So in this case, we will not wait for the email, but I have already downloaded data, so I will show you how it looks like. So this is how the data looks like now. So now this is the data from NOAA. You specified this range, you have all the variables over here, and every variable has a code name. So for example, precipitation is PRCP, snow is this one. This is T average is the average temperature, T max is the maximum, T minimum is the minimum temperature. This is the station ID now for the Dallas, and then its name is also mentioned. So everything is over here. So right now you have downloaded a data set, using that website by yourself, putting order everything. Now, if we need to do this entire, activity through Python, how we are going to do that? So that is what I'm going to, tell you now. So now that we know that we are interested in, say, for example, this Dallas station, and we want to download data from over there. So if you want to access this exact data from Python, you will need to have a web service token. So all these services that that you want to acquire, you will need to have your credentials. So for that reason, if you are going to download data from NOAA, you will need to request a web service token initially. because that will be your authentication that will go from the Python and you will download it. I will show you in the exercise later on, but I'm just telling you these are the initial steps that you should perform in order to reach and access data. So web service token is important. It is easy. You go write your email and then they will send you a confirmation and then you will have your password and everything. So next thing, as I showed you, you should know which data set you are interested in, and then you should know which, place you are interested in and what is its ID, because everything you are going to gather together and you will stitch together, make a URL using, you will be using API application programming interface to reach to that particular data. So once you have everything over here, so this is just a snapshot of what I showed you in my Excel file. So this is the data that you downloaded, say from the NOAA website. So now in our case now, for example, we are interested in downloading precipitation data. So we will now require NOAA's API to access the data. So every website has a basic API, base API, and from that onwards, you should put in all your details specific to your requirement, and then you will make a complete API, and then your if you're using Python, in this case we will be using Python, so that will now complete that URL and then download data for you. So in this case we will be downloading precipitation, and then later we will have exercises related to other data sets also. So for example, now you know that okay, I want to download precipitation data, and you know the data type code now is PRCP. Now how do we generate this API for NOAA? So this is the step. So NOAA's base API request is this one. So everything in this over here is the base request. So this will always remain same. Everything that comes after this question mark is user specific now. So for example, all the majority of the station have this dataset ID that start with this prefix GHCND, Global Historical Climatology Network Daily, and then the data type ID that is upon you. So for example, in previously over here I showed you data type code as PRCP. Say for example, now you are interested in average temperature, so you will specify. So here we have specified T average, which is the data type code. And now this is the limit. So limit is actually the maximum number of items that in one URL could be included. So the maximum that you can do is 1,000. So for example, you want to download data for say 4 years. So 4 year data each year, if it has 365 days, that is more than 1,000. So it will not download, the data for complete 4 years. So it will restrict to the 1,000 days only. So if you want to get multiple year data, you'll need to run a for loop, we'll see that. So next comes the station ID. So in our case that I showed you via manually, via website. So our station ID, we know that it is Dallas station and it has an ID and we got the ID from website. And this is the start date and the end date that you need to specify for yourself. And this over here, for example, is the complete stitched API, the complete URL that you can see that after this question mark, you can see this green dataset ID shows you GHCND. Then data type ID over here shows you this T average because you want to download average temperature. Limit you have specified 1,000, but if you are going to download for 2015, you can keep it to 400 because that will be always lesser than 400 because 2015 might have 365 days of 366 and 365 I think. So then station ID, your station ID, you will enter over station ID over here, and then start date. It's the first day of 2015, and then the end date is say last day of 2015. So once you specify whatever your requirement is, now you have a complete API request that is ready to be sent to NOAA that okay, we want this. But how do we do that? Now we will do it. I will show you how to do it through Python activity. But before I go to that, please let me know if you have any questions, any confusion, because next is going to be all activities. So I just wanted to make sure that you understand what we are going to do. So please feel free to ask any question. If you have any confusion till now, please you can unmute yourself or you can drop a message in chat box, whatever you find it appropriate.
Would we have to include all of these IDs? Would,
Which ID? Sorry.
so in the link at the bottom of the slide,
Hmm.
would we have to include all of that information to access the data?
So yeah, so you will generate, for example, this API, in the script by yourself. So you will need to enter all the data that you already know. For example, station ID, which is your station ID. You will enter it over here. So this can be different for different people. So whatever it's you can see in the green, color. This is just user specific. Whatever that is dependent upon your requirement or your specific objectives. Once you fill it, then I will show you now later in the Python activity how this is going to generate API and download data.
Okay, thank you.
Okay, so if there are no more questions, then I think let's move forward to the activity. Yeah, so all of you can go to this data access on my Hub, and under that you can open this activity 1A, but you can run it also by yourself. But uh, I think if I go through step by step, then you will be in a better position to understand what is happening. Then we will have another activity 1B, and then after these two activities there will be you will be given a interactive activity where you can play with the Python code and then be able to understand. And please remember to terminate your session as once you do your activity. So let me mm, so on my GeoHub, so in the data access you can open this activity one if you want to use it. Okay, I already have a session in place, so I will open it from there. Okay. So are you all able to open this activity one? Is everything all right? Can anyone just let me know so that I can start? You need to go to this on Tuesday under data access. You can see all these you know Jupyter notebooks. You need to open activity 1A right now. Um, can you access it? Can anyone please let me know so that I can start? Or if it is not opening, can anyone tell me? Yes. Okay, it's working. Okay, so let me start with activity now. Thanks for letting me know. Okay, so the first cell, I am going to explain it to you line by line so that you understand. Okay, so it's working for. Okay, thanks for letting me know. Okay, so the first step. So as Tanner, I think comprehensively and explicitly told you how to how we import different libraries using this import function. So for this data, now we are going to import different libraries, in order to access data from Nova using Nova's API. So request is one of the libraries that you will always be using to access data from different websites. So it is a library that requests whatever you make your API, and then it gets data from there. So for this activity will be using request library, and then we'll be using pandas. And I think you already know panda is for like data manipulation analysis. One of the you will be using it a lot for your data. And then we'll also be using this JSON library. So JSON, it's just I will not go into detail, but as a it just brings everything from the website in a human readable manner, so you can you can see by yourself. And then you can whatever variable you're interested, you can get from there. So I have commented these two libraries I will not going to use. So please remember whatever you can write any stuff in the Python, in any cell. But if you are not going to use it, you can just simply use this and make it a comment. So Python, the it will not be read by the Python. So it's just a comment. It's not going to affect your cell. And then we'll also be using date time library, and I will show you what's the purpose of date time. So now I will run this first cell. So it's run. So you can see a number next to it. When there's a number, so that means that is run. So now coming to the tokens. So as I told you, for Nova and for different websites have different, ways. So some websites may ask you for a username and password, and for in case of Nova, they want a token from you. So the first step that I showed you, you need to have a token from Nova in order to access data and download it from Nova. So in this case, this is the token that I got from Nova, so it's already for you guys. So you guys don't need to, get any token right now. But for future, for any data you want to download, so of course you will need this token because that is required to access. So now I've run this also. So we are right now interested in downloading data from Dallas Fort Worth Airport Station, and now we already know what is the station ID because we downloaded this data manually, so we know the entire station ID and what is everything else. So we're going to run it. So it is being fed. I am assigning variables like token, station ID, everything. So you can change these names as per your convenience. It's not like specific that it should always be like this. Now this cell is going to create an empty list for dates, precipitation, and then precipitation because we are eventually going to get data in format of dates. Next to dates, we have precipitation values. So this is an empty list. Later, we'll run through the script and we'll get values into it. So this is a list, but if you want to check what is the type, you can always type and next to it write the variable and it will show you the list. What is the type? So over here, it's list. And now the year, so for example, in this case, we are interested in year 2014. So we have written str, before this 2014 bracket. So this because this API will read this as a string only. So we need to convert this value number to string. So that is why we have written string. If you don't write it, it will return an error. So the data type that right now we're interested in is precipitation, and we know what is the code of precipitation. So it is PRCP. So we are simply going to enter that code over here. And now all these variables, Python is storing these variables. We haven't done anything. We're just assigning these variables, that this is the data code, this is the, now comes the important step. So we are now going to make an API call. So this request library that we imported at the beginning has a function called get. And next to get, you need to put all the API. So as I told you, till this, over here, till this question mark, this is the base API now. This will always remain the same. So after this question mark comes, what you want from this, from this Noah website. So you have specified your dataset ID is equal to GHCND, or you can assign a variable, but it is always fixed, so it's written in this. And then data type ID is equal to this plus data type, because this data type over here you have already mentioned is PRCP. So remember, you can add this plus. So plus is actually stitching your this URL, and then you just follow this API that you need to put limit, then station ID, and then station ID is this variable station underscore ID that you have already mentioned over here, and then year, then this start date, end date, and then this is important token. So token means over here token. So this token is already over here. So if you don't have a token, this is not going to work. So this is not going to return anything. So now I'm going to run this one. So this now assigns this or everything to a variable called R. So everything is now stored in R. So now we are going to read this R as a JSON using this JSON library to see what we can get out of it. So we are going to load it into a variable called D. We will call the loads function from JSON. So when we run it over here, so you can see it is now the data that API generated from this website. So you can see in the results, you can get this, you see this data. The data type is PRCP, station ID is mentioned, and this is attribute, and then value also next to. So 0 means no precipitation. So everything has been, taken from that website and loaded, and that is being showed to you. So over here, so for example, right now we are only using this for PRCP only. So in a case where you are interested to see all the variables, what, for example, you can see in this Excel sheet. So all these variables. So in that case, you will just modify your API, and then that will show you everything. But for the sake of simplicity, we are keeping it simple. So it's only PRCP now. So the next step is that now what we are going to do is, for example, as I told you, if in any case, this is only for the sake of your understanding, in any case you got an website content through this JSON, which has lots of variables. Say it has temperature also and everything. So but you are interested in only PRCP, so now you will make a script out of it using Python. I think for many of you, because who are new to Python, I understand it might be hard to comprehend what is this basically syntax telling you, but I will explain it in a simple manner that this basically is only asking that, in this results, get me only that data type that is PRCP. So I only want PRCP data from this, whatever has been generated in this, from this JSON. So now over here, it is actually, it looks exactly similar to this because, our base API was also calling PRCP only. So there were no other variables. But in a scenario where you load everything from the website and now you want a data type only PRCP, so you will mention it over here. So after mentioning it, now you can call this PRCP, running this code. So this PRCP variable will tell you what is in this variable. So you can see you have everything from date wise. You can see all the values. Now, next thing is that, you want to extract date out of it also, because the ultimate objective is to get a time series of days and then precipitation value. So you will make a Python code. Because of, lack of time, because we have to do lots of activities, so it's not actually because of the shortage of time, I may not be able to go through each, write each, the syntax, but I will try explaining you. So for this, syntax, you are getting date for items in PRCP. So, in this PRCP, you have date also over here. So you are going to extract it using this function. So you can see all the dates with whatever dates are over here, you have extracted it as a dates PRCP, in a variable. So next, now we are because interested to get values of precipitation. So you can see there is you can see value from title in this PRCP variable. So now you are going to call values out of it, because step by step we are going to make a code to make a file where you have dates and then values. So now we have got dates also, now we have got values also, but there is a problem. If you see these dates, these are actually Python will consider them as strings, and they have a different format also, like year, month, day, and then there's a t written next to it. So this is something from and then hour, minute, and second. So this is something from the Nova, but we want to make it look like proper date, like only day, year, month, and day. So so before that, we create an empty data frame calling df PRCP, so that we will store everything that we got, dates and precip to that data frame. So it is empty. So you can see, so I am duplicating everything. So I'm making an empty data frame and then calling it next to it, so that you can actually see what is inside it. So it's empty right now. So nothing, there is nothing inside it. So now in this data frame, in this empty data frame, we are going to make a new column called day. And then we are using a library, Python library, that is date time, and its function strp time. So this actually converts this string, whatever is the strings, we tell it this for the format of the string. So for example, in this case, you can see the format is year, months, day, t, and then hour, minute, second. So we want to get date time out of it. So we actually write this in the exact manner that is on the website. So for example, in this case, it is year, month, day, and then we have a t over here, then hour, minute, second. So this, what this function is going to do is that this is going to convert that string into a date time. So you will see now we have a date, proper date, year, month, and day. So this date time is a very useful function. And next thing over here is that in this df PRCP, the empty data frame that we created, we want to make a column called precipitation, and we want to get values of precipitation in it. So this v is it's a variable that you say that you want, for example, in this case it is a bit complicated over here because I have introduced a formula to convert these values to millimeter. So that's why you can see this is a formula divided by something, but I will show you a simple example later on also. So what this is going to do is that this is eventually going to do to give you precipitation values and in millimeters. So now over here you can see you have a date column, you have a precipitation column next to it now, and then these are zero values because there might not be rainfall on these days. So this is the end product that we got using following these certain steps. And now we can simply save it to a CSV file using this, DF precipitation to CSV file. And then we write the name, whatever name you want. And then we don't want index, so we are writing it index as false. So don't, there will not be an indexing. So we are going to run it, and then in the home directory, if you go, you can see this precipitation file has been generated just now, seconds ago. So over here, everything is stored in this precipitation file, date and precipitation. These are in millimeter. So this is an some sort of steps that you go through, but once you have developed it, so it will be super efficient, super fast. You can get any variable, any time data. So yeah, before I move further, if any questions, please, most welcome, because
I believe there was
so
one question in chat about
yeah,
the
the
API call.
question, do we need to write whole this in the API? Yeah, exactly. We need to write, because otherwise, if there is something, if the API is not complete, so obviously, if anything is missing, so API is simply, let me put it to you. So for example, this is this website and it has a URL. So for example, API is something like URL because it is now going to access this website using the URL that you mentioned. So for example, this 2005, I removed this 005. What happened? It says error because this there is nothing over there. So if you give it a complete URL, so this is basically what API does. So it will now reach to the point where your data is present. So that is actually important. uh, okay, so yeah. Okay, let me move to the next part. I know it might be hard because, initially, if you don't know the syntax of Python, so it becomes hard to, comprehend what is happening around. But I think you also need to follow that what we can do through Python using, like how we can access that. And later on, as you dive deep into Python, so things become more easy. So this is just another illustration that tells you that, how we can download data. So this data we downloaded it only for 1 year. So if you want to download it for multiple years, say, for example, over here it's written from 2018 and goes to till 2020, but this 2020 will not be included. So Python, this syntax doesn't read the last one. So it will be only 2018 and 2019. This is how this syntax works. So now you can see everything is over here, which we did step by step. We have put everything over here: token, date type, station ID, and then everything we are going to put it in a for loop. That's it. We are going to do nothing but just it's a for loop, and then we are making it iterate through years. For example, for 2018 and then 2019, and then this year will keep on changing, and it will simply give us everything. So all the activities that we performed, we have simply put it in a for loop, so, and specified range. So range has different functions. You could have specified two also, because if you want to get data for 2 years, because the range but you need to then change your API. So but this is a simpler version. So once you are done, then simply create empty data frame and then run it. And if you see, you have this data now. For example, let it run. I think it is giving an error. Okay. Okay, let me restart kernel. Okay, so basic idea is that this you can loop through, make a loop for loop out of it, and then everything gets in order, and you can download data for different years. So that is one part, and then the next part comes. So for example, now if you want to change your station, you want to change, you want to download data for a different station. So all you need to do is simply change the station using the station ID, and then you can run it, and then it will download all the data for that different station. So this is what that does for you. So for example, over here, I specify different station over here, and then I repeat everything. So I'll quickly go through it just to make sure. So now it is a different station now. So you can see we are going through all those similar activities, and then we are running it, and now we are getting the same thing, but this is a different station. But our variable is still precipitation. So and doing this, you can you can change your station. So instead of manually going to website every time, you just can go through it and do it for different station. This is because if you are only interested in one variable, say precipitation, so that makes your job easier. Before going to next activity, that is about temperature. Actually, we're getting short of time also. So if there's a question, please ask before I move to the next activity. It is more or less similar, but over here we'll be changing only our data type. So earlier we downloaded precipitation. Now we are going to download average temperature. Uh, exactly same syntax, nothing
Uh,
changes. Sorry.
Sorry, I was gonna ask something. Where the final code save the file CSV?
Oh, okay. So in this case, for example, you know, wherever you have your sorry. So you can check your sorry, there is no. So you can check your home directory always. So this is OS is the operating system library. So this functions of OS, that is called get current working directory. Sorry. So you can run this and see where is your current working directory. So everything that you download, that will be saved to your. So in my case, it is in the data in this user data access scripts, which is my this folder. So it is downloading everything over here. But in case if you want to download it to a different directory, you can use this function that is called change directory, and you will need to specify a different path over here. For example, you want to change paths, so you will add a new path over here. Say for example, whatever that path is. So that will change the directory, and then it will be saved to a different directory. Does that answer the question? Is it okay?
Yes, thank you so much.
Okay. Okay, so moving to the next part because we have to go through three more activities. So sorry for if I'm rushing through, but please feel free to ask any question. And then the next part is it's the same thing. Now, earlier it was precipitation, this time it's temperature. So you are going to do nothing but simply run through all these steps that we have gone through earlier, creating everything. But this is the important step, this data type. So you are now changing it. So now you are changing it to T average. So it was earlier precipitation, but you are doing it T average. So but now your API call will change because your data type is different. So your API will so this you will take you to average temperature instead of precipitation earlier because you were earlier interested in. So you can see what this JSON load. So this is giving you T average and average temperature value over here. So this is simply if you want to segregate, get data in a different manner. So you are only running through. So just what you are required to do is get one code, Python script in order, and then that's it. Then just simply change it. So for example, we created a data frame with average temperature. Now, because it's a temperature value, earlier it was in 10th of degree Celsius. So you can see these values. Actually, this is 9.1 degrees Celsius. So we wanted to get it in Fahrenheit. So we introduced a formula. So float actually, as already been told, so float gives you values in decimal points because these are all decimal now. So so that's why we made a for small loop in it, and then we introduced it. whatever mathematical function that is to convert values from tenth of degree to Fahrenheit. So you can simply do that. Or if you are not interested, if you simply want to get those tenth of degree, there is you can simply delete everything, and with p I think you can let me show. So you see, this is the exact same values that you are getting over here, 79, everything. So I didn't change. I just wanted to make it like that. Or if you want to change it, for example, if you want in exact degree Celsius, you just change the formula over here. So it's 7.9. So that is what this Python can do for you. So you can now simply save it in a data frame, dftemp, and uh, and then to a CSV file. That's it. I think now we will have a activity. So what you guys can do, so you can go to the this my Geo Hub, and can you please load this activity one student Jupyter file? Uh, is everyone able to open this file?
Yes, sorry, I have a question. So every time we open one of the files like activity 1A, activity 1B, we have to uh, select the something called like start new session, or we have to terminate the previous one.
So you mean, for example, if I launch this from here, yeah. So
Yeah,
if there is already a session in place, so then you will need to terminate that session, and then once you terminate, you go back and then launch it again. So it will directly lead you to Jupyter Notebook, because I already have sessions in place. So I am also seeing the same thing. So you might have some session already opened. So you need to terminate that first, and then you can load this one.
there is no way to work each other at the same time.
There is a way. So, for example, if you can simply go to, if you can open this Jupyter notebook, I think Tanner also showed you a way of doing it. So let me also show it to you. So there's another way also. For example, if you have files on your PC, say your home directory. So you go to this resources in this tools, and in the tools, you just launch your Jupyter notebook and then launch this tool simply. And then because my session is already started, so in progress, so I'm starting a new session. For example, if you guys, if there is no session, you start a new session from there, and let the new session. So over here, this is your now home directory. So what you can do is that this is another way. So for example, if you have these files, all of these files which are on the My Geo Hub, if you download these files and these are on your system, you can simply upload them from this system. And then once these are uploaded over here, you simply click to any file. So for example, I have this file, I click it and then it runs. But because if there are a lot of files running at the same time, so it will put a lot of load on the server. So it's not recommended. So you should, it's better to terminate before we move to the next one.
Thank you so much.
Welcome. So for this activity, you can, if so everybody has this file, can you please let me know? Uh, I assume everybody has this file open. So what you can do is that you can now play around with this for like, I think 5 or maybe 10 minutes before we are short of time. So you can just simply, so choose one variable among this T average, PRCP, or WDF5. So these are all written mean temperature, precipitation, or direction of fastest 5-second wind. And then you have this station, different stations IDs mentioned and their names also written next to it. So you can change, you can put whatever station you want to try, and then try the variable. So for simply for changing station ID, you will need to write, you can copy it from here and paste it. So for example, I want to run this one, so I will copy it from here. So and then paste it simply over here. And then you need to change the data type. So for example, this one is WDF5. So if you want to try this T average, you can simply, write it over here. So now this will update your API, and now because you want to get the same data in your data frame also, so we'll need to change it this over here also. So once you are done through these steps, you can simply run the script and see output. But there is an important point also. So not all the stations in the US particularly, because these are all stations based in US, not all the stations might have all variables. For example, this Excel sheet over here, this is the daily summary data. So most of the times stations which are situated at important places, or you may say which cover all these variables, will always have these variables. But there are some stations which don't cover all these variables. So if you put any of that variable, so you that might return an error. So you need to make sure that that station where from you want to download data should have that data type. So for example, I've changed it now. So you can also run it, and if there is an issue, please let me know. So just play with this script for like 5-10 minutes before we move to the next one. So you see now I changed I changed the station ID, I changed data type, so it is doing everything for me. It is giving me values. So the script is already in order. So what I am only doing is changing my station and my variable. So it is giving me, and then of course you can change this column type according to your convenience. That is entirely user based. So because this is now temperature data, so we can change it to temp now or whatever. So yeah, so that is adding because your data frame was already stored. So it is now going to add it to your data frame. So you can simply, because that was already stored on your system. So if you want to do it, you can restart it and then run it again. So it will create one data frame for this. And yeah, please, you know, take a look at this script before we move to the next one. Let me know if you have some questions. Yeah, there is one important thing that always keep this in mind, that whichever website you will be using or getting data from, so this token or the credentials that website will always require. So you must have these credentials with you. So for the sake of this activity, of course, this is a token that has already been provided to you. But in other cases, for example, there's a different website you want data from there. So they mo you may in most of the cases will need this token or credential. So for the next activity, you will see that we will use a username and password to get data from a different website for. So I think we will spend, let's wait for 2-3 more minutes and then jump to the next activity, because we have to go through 3 more activities. So the idea of this data access module is basically to, because I can understand it might be very hard for a lot of you to, because if you are new to Python, you don't know syntax, and then everything you see these scripts, yeah, it's hard to comprehend, and it looks that it is very difficult, but apparently it's not difficult. It's only a matter of understanding, first you need to, the important step of writing a code is just make a sketch in your brain that these are the steps that you want to go through. So the step that you want, then writing a script will always be easy task. And then of course, most of us, like engineers or not from the computer science background, so of course nobody might be proficient. So all we need to do is that we need one sort of data from Python, or we need to process that data, or we need to analyze that data. So It's not that you need to be proficient in everything. So it's only a matter of, getting familiarity with the most relevant libraries that are going to be used. And then if you run into some problems, everybody who uses Python runs into different errors. So there is a lot of help available online. In the previous session, Tanner also showed you various sources. So for example, the Stack Overflow is a very, very helpful place. So, whatever problem you may encounter, rest assured that that has already been faced by someone in the, in past. So a solution will definitely be available on the internet. So don't worry about that. It's just a matter of practicing, and then you will, comprehend, and then you will start seeing improvement in yourself. Uh, so I think let us start because our break is due after 30 minutes and the next activity will also take some time. So I'm moving to next activity and I don't have any questions also. So okay, let's move. And now please make sure to terminate sessions, of course we don't want to put that much load. Okay, so the next activity is downloading stream flow data from USGS. So as I mentioned earlier, USGS is a very vast platform. There is a lot of data available on USGS, but you can find satellite data, you can find stream flow, meteorological, lots of data. But for this particular activity, we are only concerned in downloading stream flow data from USGS. So this is a very specific, script or library that you are going to use. So it is not one of those libraries that, like for example pandas or numpys. So some specific libraries are also available, and you can use them to get whatever they can offer you. For example, this USGS has so much data, but say for example you're from water resources, I assume. So for example, I am from water resource, so I am only interested in getting stream flow data. But if I go to USGS website and I go through steps, so there is a bunch of data that is available, and I will need to, scroll and select and specify my, particular data. So that will take some time, and then, you reach to a point where you get this data and then you start analyzing it. But data retrieval, this is one of the libraries that has been developed that gets you data from USGS, and it uses a service that is called National Water Information System, NWIS, and it offers different services. So these services include instantaneous values, which are like after every 15 minutes, and then daily values of discharge. It also gives you site info, gives you discharge peaks, discharge environments, and water quality samples. But again, whenever even if you get this data through website or through Python, there are lots of parameter codes or codings that are available, and you need to understand what those codes mean. So I'm just giving an overview so that it doesn't become so complicated. So for example, in USCS, discharge has a code of this 00060, temperature of this, and then gauge height. So you need to understand what is the code, and was it measured physically. So of course discharge and these all are measured physically. So these are just an overview, because when you will load this data, you will see a lot of these codes, and you might need to put these codes to get this data also. So you need to know what is the code for, maybe discharge or gauge height. And then next thing, so this is just an interface of USGS website. So you can see a whole bunch of so many data sets that are available over here. But say, for example, you are only interested in streamflow. So if you see this website, it might be a bit messy also to go and then select your data and then go through certain steps. First of all, find this site number, site type, and then, check mark their, requirement, their criteria. And then at the end, you might, make some error, and then it doesn't give you anything. So using these, function libraries like data retrieval and their services like NWIS, you can straight away go to the, the data that you want. So again, I will be specifically spending some time on letting you know about this criteria and codes, because this is important. So whenever you are stuck with USGS data, make sure you go to the criteria and codes and write whatever you have it in mind, and then it will tell you the code and what does that code stands for. And so the next thing is that everything, site has details available. So USGS has number of sites, and these are surface water, groundwater, atmospheric, spring sites, and every site has a code also, and the type of functions that, for example, this is a site, stream site. So stream site has a site type code ST. So when you will get this data, so that will only mention site TP this code, and then it will tell you this is ST. So what does that ST stand for? You should know that, okay, this is stream site, because sometimes you might only know the station code, but don't know whether it is stream, coastal, or ocean. So that is why having an understanding about these codes is important. And then talking about this code for site details, so of course these are also important. So these are all bunch of codes. So this is an overview. What does this? So if you are downloading data for discharge peak, so what does that peak code mean? So for example, every code has an association. Say for example, over here, this 7 means that that discharge peak was an historic peak, or 6 means discharge was affected by regulation or diversion, or whatever these codes are. And then similarly for gauge height, and then every parameter that USGS publishes, it has a code also, qualification code, and then that tells you, for example, if A is written, so that means that that is approved for publication and a review has been completed. But P code means that that is provincially, and that it might be subject to more revision. E means that that is just an estimate. So this is just a type of codes that you will see in the next activity. So that's why I'm just trying to make you familiar with this. And then this one is code for discharge field measurement. So for the service that is related to field measurement, so actually USGS sites, different agencies go there and do measurements periodically. So they use different methods like current meter. Some are also using radar, different sort of technology. So this field measurement service, if you want to use that, will give you a lot of codes, and then from those codes you can understand what is this, what does that mean. And similarly, if you want to get water quality data using this data retrieval library, you see a lot of codes over here, and you can go and search and see what does that code stands for. So it's just I'm just letting you know. So I think this was just an overview letting you know about these codes, and now we will move to the Python activity. And so you can under data access, you can open this activity 2, and I will show you how it works. So I have already opened it in my Jupyter notebook, so that's why I'm not going to my GeoHub. But if you go to my GeoHub in data access, you can open this activity 2 file, and then it will load this activity 2. And here is the thing. So okay, before I start, is everybody on board? Do you see this Python? Can anyone just drop a message or answer? Uh, Are you able to open this? You can load this file from data access in activity 2. Can anyone please let me know if you are able to open this one?
Yes.
Oh, okay, thanks. Okay, oh, thanks for letting me know. Because I'm only reading the chat, I don't know. Okay, so so in order to because here is the thing. So this is a data retrieval library that is exclusively made for some specific functions for getting data from USGS website. So you need to install it using this pip. Pip is actually a Python package manager. And make sure when you install this library, you will need to restart kernel using this kernel and restart so that it loads it, because most of the libraries are already installed. They are built in on this my GeoHub, but this one is not over here. So for example, in my case, I have already installed it, but in your case, you may need to will need to install it. So you will use this pip install this, this is the syntax for it, and then it will install this library, and then you can avail this service. So in our case, so I will simply load it. So I am just importing this data retrieval and its function NWIS, because this is the function that we want to avail services from USGS. So services which are available from NWIS are instantaneous value, daily values, site info, discharge peaks, discharge measurement, water quality sample. So this is pretty simple. It's not hard. Only thing that you should know is what is the parameter code. For example, for water temperature, the parameter code is this 00010. For discharge, it's this. For gauge height, it's mentioned. So once you know what is the parameter code, so you can get these values. So the way we call it is that NWIS is the function, and then it has a further extension that says get record of site. So site is already mentioned over here. So it's a site over here in Dallas, and what service we want to get from here. So we need to mention. So all these services are mentioned over here in brackets. So for example, for instantaneous value, this is for IV, and then the daily value, this is DV site info use. This is we call this service writing site. For discharge peaks, you write peaks. For measurements, this is so every service has a code. So you will just need to plug in the service that you want to avail. For example, I am calling it as in a data frame, and I'm getting record of this site, and I need only site basic info right now. So if I run it over here, so you can see it gives me a data frame, and it gives me everything, every detail that is available specific to this site. For example, telling the name of site number that USGS has for it, lat, longitude, decimal, everything. And then here comes the thing, this code, these are all codes. So in order to understand these codes, because you cannot memorize this. So every time if there is a code you don't know, you will need to go back and see what does that code stands for if you are interested in those codes. If you are only interested in latitude, longitude, or some other things you are already getting and you understand, then it is fine. So it will give you the basic site detail info. So the next step over here, now we are interested to in getting daily values for the three parameters: water, discharge, and gauge height. So what we are going to do over here is that now our function syntax is different. So we will specify sites as site, because our site remains the same. Service we change is now, earlier it was site, this time it is DV. DV stands for daily values, and then start date, end date you mentioned, and then this parameter code has to be mentioned. So which variable you are interested in. So in this case, we want water temperature. So you will write your syntax accordingly like this. Once that is done, so you store it in a variable called df. Now you will run this code, and then this will return you the values, for this water temperature for this specific time period. So you can see it has maximum, minimum, and mean water temperature. And then this A code that I showed you earlier, that stands for that this data is approved for publication. It has gone through the review process. So this is only for your information. So you can see daily, maximum, mean, and minimum and mean value. So you can get all this data. Next is even simpler. So for example, you are interested in now getting data for discharge. So the discharge code is, you only need to change this code over here. For example, if you want discharge for the same time period and daily value, you just change the parameter code and then run it, name a variable. So this is now going to give you the value of discharge. So over here you can see there is one thing that is says radar maximum, radar minimum. So there are some sites of USGS where they keep on using this innovative technique. So there is this site, they've used radar sensors to measure discharge. So that is why it is specifically mentioned radar. But most of the sites won't mention it because they are using simple other methods like whatever others approaches. So this one over here, if you're interested in gauge height, so you need to mention that code over here, and then the rest of the code simply remains the same. So it will give you a value of gauge height same. So you can see you three different data frames and three different data sets over here. These are all daily values. So moving forward to instantaneous values now. So instantaneous values are actually values that are obtained after every 15 minutes. So everything remains the same, but the service changes now. Earlier it was daily value, now it is instantaneous value. So you don't need to do anything, just change the service, and then that will get you the instantaneous values. So now we are not seeing max, minimum or mean, because these are only one time values. So but these are, because these are all daily values, so you, for the day you have one maximum value, one minimum value and one mean value. But for instantaneous you have only, you can see the timestamp, it is after 15 minutes. So you can get this. So now we want the same instantaneous values for discharge. So you will simply run it, everything remains the same, and then you get discharge instantaneous value. Then moving forward, it's simple. You want water temperature, you just change the code. You want instantaneous value, it's simple. You will run it, and then that is giving you everything. So this is the efficiency of Python. You don't need to go to website, download so many data sets and then filtering it. If you're only interested in water temperature, you get water temperature. So for example, now we want to avail a different service that is called discharge peaks. And for that, the code is peaks. And here we don't need to specify any parameter code, because this service will only give you discharge peak. So you will, your syntax is slightly changed, and you will just simply change the, update the syntax and then run it. And now this is going to give you peak time, peak value of discharge, peak code. I showed you there are some codes also, and then gauge height. And then these are only few values. So these values are shows you some of these storm events or something unexpected that happened on site. So for example, there might be a dam failure, there was a diversion that was opened, or something happened, and then there was a peak value. So those were recorded, and you can get all these peak values. And then coming to the next service, which is this discharge measurement. So you can use this measurement service, everything remains same, you change the service and then simply run it. That's it. It will give you measurement. It gives you all detail, everything in detail. Which party measured this? What was the time? What was the gauge height? What was the discharge? Everything, control type, whatever you're interested in, you can acquire from this, using this function. And if you want to save it to a CSV file, you simply, because you have stored it in a df7 variable, so you need to run this code df7 to CSV, name anything over here, measurement, say for example 12, whatever, plus CSV, and then this will be saved to your home directory. You can see this is environmental saved. So for example, in case if you want to use it, see it in CSV. Next thing is another service that is called water quality. So if you are interested in getting water quality, you will change the service code. This is QW data, and then this is time period. And then you will simply update the syntax, and then that will do everything for you. Now you can see you have everything over here, time. So these are these water quality codes. So for example, if you are dealing, you want to know what is this P80154, what is this, what does this stand for? You will need to go to that, criteria and codes page that I showed you in the beginning, and you will see what does this code stand for, and whatever variable you are interested in, you can get it from over here. So it is like this. And if you want to save it to a data frame, you can simply do it. That's not a problem. And then, for example, now this is only one station. So the efficiency of Python is that you can get data from different stations. So in this case, I am just showing you an example. So for example, I'm using two different stations. One is this Dallas and the other is in Houston. So you can see the syntax remains exactly same, but my site changes only. So this over here is site one, this is site two. So I am introducing two different sites, and I want to get their data. So I run it for one. So dfn1 is the site one. So this is the Dallas site. You can see over here. So DFN2 was the other one for the Houston. Now we have two different sites data. So once we have this in our data frame, so using pandas, you can do a lot of analysis. So over here, what I'm showing you is that now I'm merging these two data sets using function of panda that is called concatenate. So it will merge both of them, and along the axis, one means along column. So column wise, you can see they will be merged. And now you can see this is both are merged now. So we can see all these values next to each other for these two different stations having discharge values. So this is the efficiency of using Python. You can simply get data. You can put them next to each other. Now what I'm going to do is that this is actually a long list of code. I'm not going to explain it shortly. What it is doing is that I have these values over here. I want to make a column of date in proper date time format using this datetime library. So I'm going to run it simply so that I have this one date, column. There are number of ways you can do it, so I won't make it complicated for you, but just for the sake of convenience, that I have this column. Now what I want to do, I want to visualize them, so it's simple. So you see, starting from a scratch point where you're getting data from two different stations, and then simply you are processing it, you are visualizing it, you can perform number of operations on the data. So it took around hardly, within seconds, you can get from downloading data to visualizing it or perform any arithmetic operation. So this is just an illustration what uh, Python can do. So basically telling you how quick you can do everything. So I think we have break after 10 minutes. So we will use this 10 minutes to do an activity. So you can go to my Geo Hub and you can load this activity to students file. And it is a simply, there's an interactive activity. Just play with the code and see, for example, first, please let me know if everybody is able to open this one. So I have a question. The precipitation data download from NASA. What is the resolution? From, oh, I assume so. That was regarding NOAA. So actually, that is a point-based data. So because these are not satellite-based data that I told you, so NOAA has gauging stations on ground. So the data that I showed you was is a gauging station in at DFW Dallas Fort Worth Airport. So it is measuring rainfall value at one single point. So that's why it's not a graded data. So it's a point gauge data. I hope this answers your question. Uh, are you able to open this activity too? Anybody can just let me know, or maybe type it in the chat box so I can see it.
Which of the activity two are we opening?
So you can go to this. You can go. Are you able to access this? In my GeoHub, you can see in data access.
Yes.
This activity to students. You can simply open this file.
Okay. All right. Okay. It took me to Jupyter Notebook, Start New Section.
Sorry.
My section, Jupyter Notebook.
Yeah.
I click that, right?
Yeah. This activities to students. Yeah.
Okay.
So I have a question. It is wind direction data from NASA power. Is it reliable for any any location? So NASA power, yeah, I think they go through some extensive data validation process. So it is kind of a scientific question. I think one can do a lot of research about, when you talk about reliability of data, but you can go through certain research papers that might have already used this, wind direction data from NASA power. I actually remember I downloaded temperature data from NASA power that is available at 2 meter height above ground, but it has a coarse resolution. So it was around, I think, if I'm not wrong, 0.5 degree. So, but still, yeah, I see people use it. So if you are, I think, uh, if you want to get data at any place where you don't have any other data, and if it is you are getting it from NASA power, so I think it's better to get that data and use it. I hope it answers the question. So I will quickly go through this activity because we have only 6 minutes left, and I think I understand this is a lot for you people, but it's just we just want to give an overview what you can do with Python. So for example, having said the same thing, I think you guys might need to install this library, otherwise you will not be able to run this code. Am I right? Are you guys facing problem? Their error, I think.
At the top of mine, it says download data precipitation from
Yeah.
NOAA.
So I think, yeah, I got the point. So, so I think what you guys can do is that, if you can simply load this Yeah. So you see there is this function called pip install dash u data retrieval. So you will need to you can either copy it from this activity 2 script and then paste it to the make a new cell over here using this plus button and then paste it over here from this activity and then install this library first. When you install it, then you will be able to use this function. So
Okay.
right now,
Where do we copy it from?
activity 2. So activity 2 script, you can go there.
Activity two script.
The first cell, you see there is pip install u data retrieval.
Mm-hmm.
You copy it from over here, you make a new cell. You can add new cell using this plus button and then simply paste it over here and then run this. So this will install this data retrieval library because it is not inbuilt on my GeoHub. And I
Where do I
think,
get the script?
sorry,
Where do I get the script?
this activity 2 students, it is on the my
Yeah,
GeoHub.
I'm already there, activity two, but when I open it, I see Jupyter Notebook, start new section. So I'm trying to see where the script is.
You are seeing this like this, maybe.
Uh-huh, yes. Mine doesn't have, what mine have is Jupyter Notebook, start new section.
Okay, so it says, yeah, so you can terminate the earlier section and the start a new session from
Okay.
here. So I think I am saying that pip install is showing error. Are you using this U over here, this entire, or you are missing any syntax? Because it should work.
Okay. Okay. Okay.
So
I
let
got it
me let
now.
me paste it in the chat, the entire syntax.
Okay. I think I see a lot here right now. Um, so which one is the script? Jupyter Notebook 3.
Yeah, it's this one. Activity 2 students. This is the activity script.
Okay. All right.
Real quick, so I'm not sure if there's enough time for this, but I'm pretty sure error 30 comes up when the file is in a read-only environment. So I tried running that script too. I believe when you launch activity 2, it does not have the permissions to update the libraries. There is a way around that. I don't know if you want me to show how to get around that. It involves downloading the script and re-uploading it to Jupyter.
So I think we will need to like load it through Jupyter Notebook again, and then
Correct. Yeah. It's not an issue that you guys are having. It's the way that that file is set up. Basically, it does not have the permission to install the library in the way that we are launching it.
yeah, I got it. So I think because we are short of time also, so let me just quickly just you know tell what this activity does. So once if you have, for example, installed this library, so this is also a lesson from here. So Python installing these libraries could be very difficult, very challenging, because different libraries are not compatible with different versions of Python. So you might need to create different environment. You might need to use different IDEs for that. So it is also a lesson learned that if you are using a portal or like GeoHub, which is already had some libraries installed, it's fine. But if you want, you will be using this on your personal computers, you will face this problem a lot. Different libraries available. You might not be able to install it in a easy manner. So having said that, so this one was a simple, activity that will change your station ID and changed your, services, and then that gave you different, all these values. So this was just an application of how you can play around it. But I think, so what we will do is that, so but in order for you to run this file, you will need to install this, library. So I will make, I think I will upload an instruction sheet, in this data access for all these activities. And you can then create a new file and then you will go through step by step installing this. library and then using all those functions. I think that will be a activity worth it, because this is an important point. So I think this is break time. I don't want to take much of your time. So after 15 minutes, we'll start the next activity. Welcome back. Can you see my screen? Can anyone just let me know my screen is visible?
Yes.
Okay, thank you. So uh, I hope everyone is back, and let's start resume the lecture. So now this part of the lecture. So now we will be I'll be telling you about the activity 3, that is downloading netctf files using Aphrodite data and its temperature data, and then converting it to a time series. Uh, Before we go to this Python exercises, I will just give you a brief overview what a netctf file is, how that could be downloaded using this website, and how we are going to download it using Python. NetCDF is its abbreviation is Network Common Data Form. It is a file format for storing multi-dimensional scientific data variables such as temperature, humidity, pressure, wind speed, and direction. So over here, so you can see two images. On the left, it is the temperature data, and on the right, it is this pressure at specific locations. The locations are highlighted over here. So this netcdf file can store your variable in time. For example, and it also shows this special data in your entire special extent. For example, this extent, whatever it is, it has temperature value in each pixel, and then it can be for like any time instance, so it can be monthly or daily. So if it is daily, so for each day it will be different. Similarly, if it is for pressure or for any other variable. So what is Aphrodite? So Aphrodite is actually only for the Asian region. So audience from Asia might be interested in it, in this data set, because I know in countries like Pakistan, because I'm from Pakistan, so I've observed the data is not easily available. And if you want temperature, precipitation, particularly, most part of the country is ungauged. So Aphrodite, for example, or such, or different satellite products you can use, and then you can download this and get precipitation or temperature value. So this Aphrodite data gives you precipitation and temperature data sets, which with some reasonably good spatial resolution, such as zero point 0.5 and 0.25 also, and it has a temporal scale of daily. So for this example, we will be downloading an netcdf file of temperature from Aphrodite, and that will be 0.25 degree, and that would be a daily data file. So, for example, as I told you earlier, for example, if we are not using Python, and if you want to download this netcdf file without Python, so what you will do is that this you will go to this Aphrodite Water Resources website. So in order to download data, you can go to its index where they have stored this netcdf file, and you can download it simply manually, going to the website. But if you are going to download it via Python, then again you will need to make your account on the website, similar to what I told you for the Nova. For that Nova, they wanted you to have a token. For this website, they want you to have credentials like username and password, and then you can access it using your API and download this data. So, for example, if you are downloading a data netcdf file manually, how will you download it? So if this is the index of the temperature product. So these are all netcdf files year by they are stacked year by year. For example, this starts from 1961, goes up to latest time period. So if the website URL, you can go there and you can click on any of this, and you can download that file, and that will be a netcdf file. Say, for example, if you click on this, if you go to website, click on this, it will download a zipped file, and you can unzip it, and then that will be the netcdf file. But here is the thing: if, for example, you want 40 years of data, so what will you do? You will click every file, and then okay, you can click file, it will take you some time, but after that, then that is a stored, netcdf file. So you need some programming language to, to read data out of it. So for that purpose, Python is a handy programming language. So it can take you from downloading, accessing data, downloading it, and then also reading all the variables, and then getting the desired, values at any point. So you can write a Python script as you can see over here. So that will require username, password, and then you can bulk download netcdf files for different years via Python. That I will show you in the Python activity later on. So before we start this Python activity, I want to give you an overview what is a netcdf file. For many of you, this might be a new thing. So actually, in a netcdf file, mostly they store data year-wise. So for example, over here you can see there is a netcdf file that is called 2000. So this is for 2000 year. And in this file, there are different variables stored. So you can open this using this. So you read it. In order to read a netcdf file, you need to have this netcdf for Python library and its function dataset. So if you have when you call this function dataset, from there you can read this netcdf file. So this is what has been done over here. Dataset function has been called from netcdf, and then it has asked to read it and store it in a variable called data. And then you are simply calling data.variable keys function. So what that will do is that will bring all the stored different variables in that netcdf file, and then it will tell you the structure of every variable. So it's basically an array. So lat over here means latitude, longitude. RSTN is the ratio of station in each grid over here. I will not go into detail because this might be confusing to many of you, and we are also not concerned with it right now. We are more concerned in this temp variable because we have to get temperature data from this netcdf file. And time is the number of instances we have for this file. So for example, for 2000 year, we have 366 days. So this shows you 366. Temp variable has a shape of 366, 280, and 360. So what does that mean? So you can see latitude over here. There are 280 latitude, values, and then longitude has 360 values. So the shape of the file right now is 366 temperature values you have it, and then you have it 280 that and 360 longitude. So for example, this is an illustration of this data. So you have latitude, from north to south or south to north, and longitude moving from west to east. So for example, this is the entire Asia region. We'll take it as an example. So this t is equal to 1 shows you an Asia region where uh, you have this data stored in the gridded format. So the spatial resolution of this netcdf is, say, for example, 0.25 for this is 0.25 degree. So that means for day one, you will have this entire extent of data, or every grid has a value of temperature, and this is only for day one, t is equal to 1. And then next you go to day two, again you have temperature data stored in all these very places, or say this is entire Asia or the area of interest. And then day three, day four, but this has entirely been compressed and stored in one file, that is 2000.netcdf. So it has these variables stored in it, and we will need to run Python script to actually to extract temperature value out of it. Say for example, I put my cursor in the middle of this, and this is our area of interest, this entire area. So this point over here will definitely have a value of latitude and longitude. So what is this latitude, longitude? If we know this, then we can run a script and get temperature value for day one. Similarly, for the same point, we can get temperature value for day two, for day three, or whatever for the entire year. So this is what Python script is going to do for us, that we will specify our area of interest as latitude, longitude, location, and then we will run the script, and then it will give us a time series of entire year, daily temperature value. So because every place has a temperature value, and that is stored in this grid. So, but we will be only for this activity, we'll be focusing on only one place where we will get temperature data. So before I move to this Python script, sorry, Uh, Please let me know if you have any question in understanding about this NetCDF format, because the script, I understand this might be a bit hard because this has a, I think, hard difficulty level for someone new to Python and also someone new to NetCDF. But I'll try my best to make it simpler and explain it to you. So as of now, if we have some questions, please ask me about this NetCDF or the structure or anything about this data set. So before I start the Python activity, please let me know. You can unmute yourself and ask a question or put a question in chat. Okay. Okay, I think everybody is fine with it. So I will now move to next slide. So, okay, so this is the illustration of this, temperature data, illustrations, special distribution of temperature data. Uh, so there is a tool when I apply, you can download it and you can see your netcdf files. You can see your netcdf file from different in different ways, like in GIS also, using Python also. But for the purpose of this illustration is just to let you know that this is the entire Asia region. So this is giving you temperature value of all these places over here. But each place, this entire image of Asia, it has a pixel value, a pixel resolution, that is 0.25, and each pixel has a value temperature. So for example, the Python activity that we are going to perform, the area is somewhere over here, say, and this is only a fixed one latitude longitude point, and we will be extracting the temperature data for the entire year for one point only, for example, where my cursor is. But we will need to run a Python script for it, and then we'll get a yearly time series at the end of it for one point. uh, so any questions before we move to Python script? I understand it might be hard for many, but in order to understand, how you can use Python to download data, different data. So it's also important to understand how the data is stored and how you can access it. So, for example, this is one example of Aphrodite data. So every other data that is stored in netcdf format, you will more or less be using this. You can use the same script, change it, and then download it if you know how, what is the place from where you can get it. So I think. I will move to the script because, yeah, I think we don't have any questions. So let me move to. Yeah, so please, under the data access tab, you can open the activity 3 Python notebook and make sure to terminate all the previous sessions. And I know many of you are facing this problem because if the earlier session is in progress, so that simply doesn't open the Python files and it takes you to the previous session. So we will open this activity 3 and let me show you where you can find it on my GitHub. So under this data access activity 3 file. So just click this file and then it will pop out. And please, anybody can, or you can confirm whether you have opened this file. Without Python, can we use Uh, can you please explain what do you mean by using netcdf data? So are you only talking about downloading simple netcdf file, or you're talking about getting the temperature values, the time series data from it? Uh, because if you see this slide, or sorry, so you can simply go to this website and you can download netcdf, getting the time series. No, for that to happen, you will definitely need to any programming language. It's not strictly like you should use Python. You can use any other, programming language. R can also do this. MATLAB can also do this. But I think because this is only you need to extract values out of it. So simply downloading netcdf file on your system, uh, the data is stored in that file. So you need to use some tools to extract data from it. So you will need some programming language, and I think Python is a efficient library. Yes. And are you able to see this activity 3? Can anybody please tell me? Like start. There is some problem, you can still let me know. Um, so is there a problem loading the file? Like you can find it in my GeoHub under data access. I see. Okay, okay, you can get it. Okay. Thanks for letting me know. So I'll wait for 1 more minute and then so everybody's on board and then I'll start this. Okay, so I think yeah, you are able to see it. So I will run this activity for you because uh, yeah, this might be difficult for many of you, but I will try to explain it, in the best possible easy manner I can, because I know as a beginner and then straight jumping into a complex form of data might be very hard, but I assure you that in future it will be very helpful for you guys, that whatever we are doing today. So yeah, so in order to download these netcdf files from this source, so as I mentioned earlier, you need to have your credentials, you need to have permission from the website, and some websites will ask you to get a token from them. The other might say you need to have an account over there, you should set up a username and password, and then using that you can access the data from the website. So in this case, this website of Aphrodite wants you to have an account made on it. So you will have a username and password. For the sake of this activity, of course, I will be using my username and password, and you can also use it. But for later, purposes, for other purposes, you can go to this website that I mentioned over here. You can click it, and then you can get the authorization access from it. So libraries that we are going to use for this activity are request, NumPy, and OS. So request, as we have already used it in the activity one. So request you will always be using this library if you have to get data using this any API. And then NumPy is actually so Tanner mentioned about NumPy in its first lecture, in the first lecture of today. So it is like it supports large multi-dimensional arrays and matrices, because in this netcdf file, actually it's an array. You can see the data is stored in a big area. So that's a two-dimensional array where you have values of latitude, longitude, and then temperature data stored. So that NumPy library, that is why we will be using it. And in future also, you will be extremely dealing with this NumPy and then pandas. These are the most widely used libraries for these sort of purposes. And then operating system, of course, because if you are dealing with some files, you are changing your path directory, it is essentially important to you will be using this operating system OS library. So first step is that I have put in already my credentials like username and password for this website. So I will run cell by cell. So the first, I am not calling anything right now. I'm just storing my thing, all the time variables. So I'm storing my username in this email, in username and password also in password. So for example, if you want to check your working directory, for example, because we have to download files over here, right? So if you want to download it to a different directory and you don't know which directory you are in right now, so you can always run this OS get current working directory. So this will tell you the current working directory where where these files are going to be downloaded. So if you want to change it, your destination directory is different from this one. So you can use this. I also showed you earlier, so I will write it over here. I will write a comment because we're not going to use it. So this function, you can use it. So for example, if your path is different from this one, say you are going to you don't want to save it in this data accept scripts, you can delete this one. You want to save it till here, so you can use this OS change directory, so it will change the directory, and now this will be your working directory, and then you can simply download your files over here. But for this activity, we are going to download it to this current working directory, so I'm not changing the directory. So now this script, what it will do is that it will execute and download files for all years except the last that I told you, because this last the syntax, the the year or data number, this is not going to be read. So it will read 2008 to 2009 only. So there are different ways of writing this, but one of the ways that we are going to use is this one. So you are mentioning the years you are interested in to download data. So we are going to download data for 2008 and 9. So again, what we are going to do over here is, because this is now multiple years, and now we need to iterate over 2 different years. So we will be making our API, like that is the fixed, whatever was is on the website, and then changing years only, because now your sent your URL will be changed, because it's not only one fixed year, it's different. So if you were downloading for only 1 year, you don't need this for loop, so you will simply write this URL and you use this request library and then download it. And then you are going to open it, because the extension is .gz. So this is a zip version. So you will be specifying this in the path also, and then that will download this 2 years data. So I'm going to run it, and it will take some time. You can see this static over here. When it turns to a number, that means our files have been downloaded to the home directory. So it might take some time, because these netcdf files are big in size, not that huge, but around 60 MB, mostly 50, 60 MB. So it is going to take some while. So now you can see a number over it. So if we go to our, yeah, this is my directory. So you can see just a second ago, we downloaded this 2008 file in GZ, and then 2008 file in its extension is mentioned. So you can see the size of file is also 68, 69 MB. So that is why it took some, time for it to download. Sorry, I was lost. Okay. Yeah, so this is one part. So this is the thing that you could also do manually. Like you can go to website. So if you have to download only 2 years of data, you can do it manually. Okay, till that point. But if you have to download number of years, and then you want to unzip them and then read temperature values, then of course this script will be handy, and this will save a lot of time, and of course. So now the next step is that this is not in the .NET format. So what we have done over here is that this is looks scary, I think, but what in short, what over here we are doing is that we know our desired extension is .NET file, but the file that we have downloaded ends with this .gz extension. So what we are going to do over here is that we are going to set our directory to the place where our files have been downloading, and we are using a for loop with condition inside it that if the file ends with this function, then you have to add this uncompressed extension to it, and then you save those files in their directory. So we are going to run it, and at the end tell us that these files have been unzipped successfully. So this is only, you can write anything over here. So this will just let you know that your execution is successful. So we are going to run this script now. So you can see it says file 2009.gz and 2008 both have been unzipped successfully. So we can go to the directory, and we can see seconds ago. So this has been now converted to netcdf, and this also. So that has been done. So we do have now our netcdf files with us. And now comes the next part of reading these netcdf files and then getting a time series out of it. So this part is actually going to be most important step, because now we want data out of it. So for that you need to sorry, you need to call netcdf library, and its dataset dataset function. And you will also be needing numpy, pandas, and os. So always remember to call all the libraries which are going to be used, in your script, and mostly you call it at the beginning because normally these libraries you are going to use. So you can also call them later on, but most of the time it is at the beginning. So we are going to run it. So you see, we are successfully able to run, and then this file happened. Now using this dataset function from the netcdf library, we are going to load this 2008 netcdf file. So it is already in our current working directory, so it has been loaded now. So now we are going to see what is stored, what are the variables that are stored in this netcdf file. So you can see 5 different variables. So with this dot variables dot key function, so you can simply see all the different variables. So you can see it has long, which stands for longitude, latitude, time. T average means temperature, and then RSTN is the ratio of station at each grid. So I will not explain it because it might be a bit complicated. And then now once you have called this, loaded this data set as in a data variable, so reading this data will tell you, give you an this file. For example, what is the title? So the titles tells you Afro MA, whatever the developer have written. So it's 0.25 degree grid, and then it tells you that these variables are all in float, like this, with different bits like 64, 32, and then dimension sizes also. So you can see this basic information. So similarly, now you know that this netcdf file has different variables like longitude, latitude, time, average. So if you want to read only one, specific variable, you can call it using this dot variables and then write the name of that particular variable. So right now we have called this latitude variable. So it will tell you what are the units in that variable. So what is the name? So it is latitude. And what is the shape? So it is 280. So that means you have 280 values of longitude in this entire, area, of this netcdf file. And so, for example, similarly, we call this longitude. So this tells us that we have 360 values of longitude, and then these are the units, degree east, and what is the variable name. So every detail about it you can get. And similarly, we are going to see about time also. So the time, it has its units are minutes since 2008 because it starts from the beginning of the year. So shape is 366, means 366 days of the year. You have this data, and now we are going to read this T average. So this is temperature. So you can see it is degree centigrade and it is daily mean temperature analysis, and that is interpolated because this Aphrodite data actually is all interpolated gauge based data. So it's not a satellite data. So they have used thousands of gauge data from Asia and then use different interpolated techniques, and then they have this grid data. And this temperature, you can see this shape. This important thing is that it has a shape of 366, 280, and 360. So that means 366 comes from time, number of times you have, like 366 days. 280 comes from this latitude, 280 latitude, and then 360 is from 360 longitude. So, for example, I showed you also this thing for if you see, or you can see this one. So for example, this has 280 and 360 latitude, longitude, and this has 366 files. This one is 1, 2, 3, 4. So this is what you are reading over here right now. So temperature is stored in this manner. So because you are interested in only getting daily temperature data, but you need to understand the structure of that variable also. So now what we are going to do is that because our ultimate objective is to get temperature data at any single point for this activity. So we are storing our variables. So this is the syntax of storing, your data variable. So latitude in the variable called lat, and longitude in the variable called long. You can simply store it. You can write any variable name. So it has been stored. Now you can see these values. So latitude, you have stored it in this lat variable. You can now see all the values of latitude. So it starts from this, and it is an array. So you have all these values, and then longitude also you can see. This is another array of all the longitude values. So you now know these latitude and longitude values, and now next step is now, because you want to download data at one point. So any point on Earth will have a latitude, longitude. So you know your area of extent also. And now, for example, in this case, there's a place in Asia, and I think this one is for Islamabad, which is capital of Pakistan. So this is the latitude and longitude of that place, any place in over there. And over here, so what we want is we want data of temperature at these lat and longitude, but that is stored in two different arrays. So what we are going to do is that we are going to make a script in this manner that actually takes index of reach to the index of these points in these arrays. So for example, over here you can see we are doing is that we are getting this subtracting this value, the desired value, from the lat array. So for example, latitude array has these all values, uh, and our desired value is this 33.7. So let me clarify one thing. There might be number of ways of doing this, of getting this temperature data, but this is just one of the ways you can get it. So you may devise a simpler method than this, or you may devise a complicated method that's all user based. So in this case, what we are doing is that we are squaring the difference of latitude and longitude. So for example, our desired point is 33.7, and we have number of latitude values over here, but we want to make sure that we reach to the exact same. So we are squaring, because if we don't square it, so later on, because we will be using a function, then I'll explain why we are squared it. So we are getting the difference of values, and now you can see if we call this diff let function, which subtracts this single value from the entire array. Now we have a different array value. So what we are interested in is that the point where our difference is zero. So for example, our desired point was 33.7. So in this array, there is a point over here somewhere like this 33.7. So in order to reach, manually it will be very hard. So you identify the index. So you can use the square deviation. So wherever that difference reaches to zero, so over there you can use this function from numpy. So here comes numpy, so it is very effective. So this is, we are assigning a variable minimum index latitude. So what this is doing is that, whatever difference we have found over here, it will, this r minimum function, what will it do is that it will directly go to that point where you have the minimum difference. So for example, there is a latitude value of 33.7 in the original array, and now our area is also 33.7. So this our minimum function from numpy will directly give us the index value of that point. So it will make our job easy, and similarly it will do the same thing for the longitude, because we need those points actually in indexing. We want the index. So you can see this minimum index latitude, it tells you that this is 194. So 194 means that in this array, so you 194 index is the point where where user wants the latitude value, and similarly the longitude also. So you are actually getting those index now. Now that will always remain fixed, because now you have reached to those latitude and longitude index. So now all what you need to do is that you should get your temperature data from this T average data variable. So it is important. Now we are calling this temperature because everything is inside this one. But before we reach to this, so there is another approach that has been performed over here, is that, because eventually what we need over here is that uh, we want a time series where you have time and then temperature next to it. So we are creating an empty data frame, and then we want to put our dates in it. So this function is actually, what it is going to do is that it will make a data frame that will have these time values, and then we are creating another data frame having temperature uh, of the same date range that we are going to create using this PD data range function. So let me run and I think I can explain. So if you then see this data variables time again, so that is this repetition. Yeah. So what we have done over here is that eventually we want in our file to have these data values like starting from day one to the last date. So what we are doing over here is that we are making a dynamic script that goes to this data variables time and then takes the first day value because we want this in our data frame, next to temperature. We can do it manually also. We can generate time series data, but the problem would be, so if we change this year, so if it is 2009, not 2008, so every time you will manually need to adjust. For example, 2009 may have 365 days, so 2008 has 366 days. So your time arrangement will change. But what this is going to do is that this is going to read the day one of from that netcdf file. So you can see this data dot variables time. So this is going to the time variables and it is getting dot units 14 to 24. So what this is doing is it is reading index. So for example, it starts from 14. So minutes, if you read this entire thing minutes since this whole thing, so you can see index will start from 0 as we also learned this today in our first lecture. So this is the first one, but we are interested to get this date value only. So our index starts from 14 over here. So 0, 1, 2 goes all the way up to 14. And then we want till this point, which is 23. But since the Python won't read the last one, so we will make it 24. So when we run this, so it fetches this value from it, out of it. So if we change it, say for example, if we do it like maybe 11 something, so you can see it is taking this CE also over here because now index has been changed. It is getting uh, these two also from starting from 11 and then going to. So, but we don't want. So we have customized it according to our need. So this is what you can do in scripting. So this is one way you can do it. There might be many other ways, but this will make it dynamic. So you will have a start date and end date, and then based on that start date and end date, you can define a date range because now it is fixed. This is the start, and now you have created another data frame having this date range starts from day one goes up to day last. So in this script, we are just creating a data frame, empty data frame based on this index data range, date range. So date range will be over there and temperature, but it is blank. There are no temperature values in it, but because we are going to get this temperature value now. So over here, what we are doing is that we are creating a DT data frame, and that has the same shape, exactly similar to time variable. So when you run it, you can see there are values inside it exactly similar to shape of this time. Time is actually 366, but because indexing starts at 0, so you can see 365. So it is actually 366 entries over here. So the reason behind this was, I will explain in the later steps. So now what we are going to do is that we have this DEF data frame over here that we have, but we don't have these temperature values. Now we need to find these values and we know where our values are, and so these values are all in temperature variable. So what we are doing over here is that we are using a function ilog. So this ilog is very handy function. So what it does is that it will select that particular index. For example, over here it is 0, so ilog will go to the 0 to this point because this is the first index, and then in the temp variable, it will again go to the 0 index because time index is 0. So if you go to this temp, maybe just let me show you. Uh, yeah, so this temp has actually everything stored inside it, all the values of temperature. So we actually want to get values out of it. So that's why, go to this temp and then, go to the first index that starts at 0 and then minimum index latitude and minimum index longitude. So what are these minimum values of index? We have already ascertained it. So it is 194 and 52. So this is fixed. So what it will do, that it will go to the temp variable where all the temperature data is stored because it's a three-dimensional. You can see the size of the temp let me show you. Can see it has three values. So this first one is the temperature, because 366 days, then this is latitude and longitude. So you are fixing latitude, longitude, and then you are changing only time index. So 0 means over here, if we run it, you will see a value of temperature for the day 1. So that means it has gone to that first index. Our minimum index, latitude and longitude, from those arrays are already fixed, so it knows where the exact location is. For example, location is somewhere fixed over here. We have fixed the locations. Now we are only going to change the time index, so that we want values for every day. So for example, if we change this time index to 1 now from 0, so you will see a new value. So now the temperature value for the second day, so it is 2008. 2nd January. So if we change it to 2, so you can find a different value for the third day. But now, because if you do it cell by cell for the 366 days, that is going to be laborious and time taking. So there is no use of making this script and then ending up like this. So what we are going to do, we are simply now, we have the same syntax over here, but we are making a for loop from here. So for time index in dt, so dt is actually, this is the structure of array. So it starts from 0, ends at 365. There is another way of doing it also. So instead of dt, you can introduce this range function. But if we introduce this range, then we'll need to customly change this, period. Because if the year is like 365, you need to make it 365. If it is 366, then you need to change it. In some cases, we might forget this because you're doing a lot of stuff. So you may end up getting 1 day less value. So something like this. So for example, to make it dynamic, we have just introduced an array which has a similar shape of that time variable of the netcdf file. So it is going to give you, values exactly similar to the number of days. So if we run it, so it will run through everything and will exactly do the same thing that we have been doing it using these, single liner. So it's only a matter of introducing a for loop. And now if we open this data frame, now you can see every cell next to date has a temperature value. So this is exactly what we were required to do. We have got it, but we had to go through a number of steps. And if we want to now save this data frame to a CSV file, we can simply call this df to CSV, and we can see in our this we will see. So this is a new CSV file created. So just seconds ago, you can note the time also. So this file has been created, and you can see. So this is temperature and everything. So you can introduce column over here or write a new column or whatever you can do with the data frame. So eventually, so the idea was to open this netcdf file. It is structurally looks difficult because you need to comprehend how structure looks like, and then you need to follow all the steps. But I'm sure if you go through these scripts and understand how netcdf file stores the data, I think it becomes easier. So this activity has no interactive activity, because I think it might be hard at this stage. But the purpose was to just make you familiar with all, because you will see a lot of data is stored in netcdf format. So it is one of the widely used format. So that is why it is important to understand how the data is stored in this file and how you can access it from there. So this example was only for temperature, but it variable can be changed. So it can be pressure, it can be precipitation, or any other. But the idea, if you understand structure, you will get to know how to use it. So I think that is all for the 3 activities. And before we go to activity 4, we have only 30 minutes left. I'll be happy to answer any questions if you have. You can unmute yourself, ask a question, or you can put it in the chat. I understand this might be a bit complicated because it's not that easily, stored in an easy format. But going through, understanding the structure and going through Python scripts and trying to understand what is written in the script. So this was just an illustration of how we can access time series data from a netcdf file. So you can devise thousands of different ways of exactly getting the same thing, but in a different manner. So that is all dependent on what user, the knowledge of user and how, different functions you can use. So it's a relative thing. So maybe can make a very simple script out of it, and some may end up making a complicated script. But uh, eventually, if you need our data, so you need to go through certain steps, and you can do it. I think it's not that. So I will wait for 1 more minute. If there are some questions, more than welcome to ask, and then we will duty go because we have only 30 minutes here. Okay, I think we don't have any questions. Uh, so from here onwards, Tanner will take the lead and before. So thanks from my side. Tanner, I'm stop sharing the screen so you can go ahead.
Okay, so you guys should be able to see my screen now. So we're going to do a little bit of a, I think might be a little bit simpler, since a lot of the energy domain stuff is going to be time series data, without having like some sort of maybe more like on the spatial data side. So if you're interested in like building domain or energy research and stuff like that, this is an example from a data set that we use in terms of like energy research. So this is the Building Genome project. There are two versions of this project. We will be using Building Genome 1. And these are basically time series energy usage data on hundreds of buildings. Genome 1, I believe, has 500 buildings across various types. So it could be offices, education, commercial, industrial. So that could mean, houses, factories, stores, universities, K through 12, that all sorts of options, right? And these give hour by hour energy usage at the electrical meter, basically. And so what's kind of a little bit unique about this is that the previous data sets that were mentioned usually have some sort of stream flow option or something that you can get fairly live feedback on updated data. So you can usually get updated data daily or weekly from this. Building Genome is not necessarily built for that purpose. If you are using something like that, you would use like the EIA or something like that. It's also kind of worth noting that this area of research in building domain um, is still fairly young. This is kind of the first project of its type to be able to like gather all of this information in one spot. And what makes this project unique is that this data set doesn't change a whole lot. And this data set is really used to be able to benchmark your methods. So say, for instance, you create a Python script that estimates the amount of energy usage or creates some sort of modeling mechanism to um, say, hey, like, I'm going to guess that this many people are in this type of building based on this much energy usage, something like that, right? Every research paper that publishes this always uses a different case study or a test set. So the point of this was that this was supposed to be a universal test bed for building and energy domain research, so that if you had a method and someone else had a method, kind of like what's being shown here on the right, you can test them all against the same benchmark data set that's building genome to see which one is fastest, which one is more accurate, which one's the easiest to implement. So this is a good way to be able to like test your methods. And methods can be just as important, if not sometimes more important, than the results that you get from your research when you perform data science. Because sometimes if you generate a new method that's unique and novel, people will be very inclined to want to use that method. So if you can prove it's, hey, this is faster or whatever, right? Um, so this data set, being what it is not updated very often. There has only been 2 real large updates to it, one of which resulted in a new project called Building Genome 2. So because of its purpose as a test bed, it doesn't need to change all that often. However, this means that it can be hosted as just a singular file. So whereas in the other cases, you needed to know like an application programming interface, like an API, or like some sort of method to modify the link or a token or something like that. This just means that you need to know where that file is, and you can download it directly through Python and import it and then modify it as you want. So this is a pretty straightforward script. There's not a lot that's going to happen in this. The data manipulation and data cleanup and data navigation will happen in a later exercise. So in this example, Building Genome is hosted on GitHub. GitHub's a popular place for repositories that people like to just host their data or code. Building Genome has its own Python notebooks, like what we are using, in addition to the data. So one method of doing this, I'm not going to ask y'all to do this, but one method of doing this is you can do this manually. You can go to the GitHub for this. You can click on that link that's in the PDF, open up the Building Genome project inside of GitHub, navigate to the section, go to the raw folder, and download and open that temporal open utc.csv. And they give you 2 CSV files to use here. And really what's kind of the important thing to note about the differences between these is, and this will be kind of a general rule of thumb, is if something says it's temporal data, that means it's time series. That's just a really kind of a good rule of thumb for that. And if you have metadata, that just helps you describe the data that you have. So in this case, the temporal data is the actual data that you're probably wanting to look at. That involves energy usage in a like hour by hour setting. Metadata, however, gives you like the square footage of that exact building, where it's at in the world, what kind of weather is it looking like, that kind of stuff, right? So this is a good way if you're really not feeling up to coding a method to download this stuff. However, I would recommend doing that. So we'll do what's called method 2, and we'll have an exercise for this here in just a moment. So method 2 is downloading this through Python. Now for data sets that don't change that often, both methods are valid for this. However, if you have a data set that does change somewhat often, using this method might work a little bit better because then you can just run the script again and re-download it without having to navigate to the website, re-download the data, sign in, or whatever you might have to do. Another nice thing about this is if you know how the link is constructed, and I'll kind of show you what I mean by that. You can use list, if you know what all the files are, to iterate between all those files, and then you can download multiple things without having to download them all at once. So this will work on pretty much any data set. Doesn't even have to be on GitHub. This really just uses the requests library. And the way that the request library works is it sends out a request. And what will happen is it will get data back, and that data you can either save as a file or import it directly into pandas. So we'll open up exercise 4. I will open it up with you guys here. So give me 1 second. Oops. Discard. All right. So I will open up exercise 4 here. This will be inside of this activity 4, .ipynb. So you'll open up that Python notebook, and then within this right here. So the first thing that we do is we import the request library, and then we give it a URL. And so what I was talking about earlier with knowing how this is constructed, when you download stuff from GitHub, you have to download stuff from the raw part of the GitHub library. And there's a lot of other data sets that are hosted on there. Some are hosted on their own websites. Talking about fair data, you may be asked to host your own data on a website for a paper that you may publish. And if you do that, you want to make sure that it's at least easily accessible so that someone could do something like this right here. So what this does is it looks and grabs this URL right here, just like you could type this into a web browser. It sends a request.get with that URL, and the response that comes back from that is going to be, I'll show you what it looks like here. So the raw portion of this, if you were to go directly into this, it will not download the file, but what it will in fact do is give you the actual CSV file, and Firefox or Edge or whatever it is that you're using will download it. And this is what the CSV file looks like. So it's going to look like a big mess. And that's because it kind of is right now. So if you download this, and what this does right here, this if-else statement checks to see if there's a valid file there. So if response status code is 200, that means that, yes, we are good to go. There's a valid file there. I finished downloading it. So we'll show you what happens. Says file downloaded successfully. Awesome. So that means that with this open command right here, we opened a new file called that, and then we saved it as a new file. So F, we write that with the response content. So meaning that we take a URL, we ask for the content through that URL, and then we take that and write it to a file. And for the most part, that's the most complex part of this. The rest of this, you probably already know what's coming. Import pandas, and then that file that you wrote, now you can import that back into pandas as some kind of data frame. So in this case, I gave it the file name that I named it. I think in the example, it uses a different file name. And then you can call the head of the data frame, which just lets you look kind of like a brief preview of what you downloaded. If you notice, a lot of these come back with what are called not a number values. This is something that NumPy provides, meaning that it's not necessarily 0. It just means that there's no data there. So there is a difference between 0 and no data. So let's just take a quick look at what we downloaded here. So if we wanted to convert this, so a fantastic example of when I mentioned about strings, right, and converting strings, the timestamps for this right here. So when you import this, Python reads this timestamp right here as a string, but that makes it very hard for Python to be able to organize that. You can't say, I want something less than 2010. It doesn't know how to interpret that. So you can use pandas to innately convert the dates using a command called toDateTime. And all I'm doing is I'm replacing the entire column of the timestamp with the exact same thing, but applying this command to it right here. Right. So if I run that, and I don't think all of these are in the example. I just wanted to show you this. If you run this, then it replaces that. And the data frame function has its ability to plot without needing to set up matplotlib if you just want to look at data quickly. So you can specify a y-axis and a x-axis. In this case, the x-axis is obviously the date, and the y-axis is the building that I've selected. In this case, I believe I've selected Office Jet, which is this one right here. And you notice that the first 4 values of this don't have a number, but there's 500, or there's probably some several thousand rows of data. And eventually it will find data that is correct for this. So if you graph this, what will happen is it will graph this based on where the data is actually valid. So outside of this, where there's nothing graphed, that's not a number. That's pretty much the gist of this whole example. It's very simple. In data pre-processing, so tomorrow's lecture, you will learn how to split these up and to be able to make meaningful like observations with this data. But if you run this and download the data for it, then you'll be prepared for the next lecture about this. So does anybody have questions about this? It's pretty straightforward, so. I guess while I'm waiting on questions, I'll go over one quick thing. So when I mentioned how the link is constructed, right? What did I mean by that, right? So what I mean by that is that if you know that at the beginning of every link is going to have this https://raw.get you know, the whole prefix of the website, right? Then you know that the next thing that it's going to say is maybe the owner of the account, and then it might be the name of the repository, and then the folder it's in. And you can generate all of these, right, using concatenation with strings. So like an example of this would be, if I wanted to update this, right? So if I went back to GitHub, the Buds Lab, yeah. So if I went back to this, right, and said, let's say I want to change this to URLs. So let's say there's more than one set of data. Let's go back to raw, go to this, and let's view the raw data. Oop. Oh, that's the temporal data. Whoops. That's what I wanted, raw. So if you get the link from that, and what you can do then is you can create a list of these. And then you can then say, let's see. For link and URLs, where you can say URL and URLs, you can loop within this list here, right? You can tab everything over here. And then what you can then do is you can change the file name to be, so you know what the file name is at the end of this right here, right? So if you do URL.split and you use this backslash right here, and if you know that it is the last term, I believe -1 is the way to get the last term. Yeah, that's a good question. So the answer to that is it's kind of up to you. Generally, it kind of depends on your application. I think for most analyses that you'll be doing, you usually acquire all of the raw data and then you pre-process it, because you don't, like, if you change your method of pre-processing, maybe you don't want to lose that data, right? So just want to make sure that you don't basically lose anything on that. So, but generally you do it like as you work. Yeah, it's a step that you do. You try not to do them together. And yeah, Jeanette's right. We will have a whole section talking about just data analysis and data pre-processing and what you will be doing specifically with that. Because to be honest, this right here, while this is a very cool graph, there's not a lot that you can make of this right now. Or this right here. So there's a lot of pre-processing that you would have to do to kind of be able to like look at that a little bit more in depth. So let's see. Let's see if I did that right. I may have missed the. Yeah. Okay. So now you should have two user files that are within this here. So basically, I've downloaded both files, this one and this one right here. So yeah. I think I'll leave it open if anybody has questions. So this is just all I was trying to do was show if you are trying to download data, you can integrate your core concepts that you learned in Python with it. So for instance, in this case, a for loop. So yep. Okay. I think I will leave it open if anybody has any questions. So I'll go ahead and stop sharing my screen. Actually, no, I'll leave this up here.
So I think if nobody has a question, maybe we can finish it for today.